Hey guys, just a quick update. This is operator level 486. Um, Operator random 1 just threw me pins a minute ago. So, crystals and pins, I got my Make Anything machine working for that one. I'll just give you a quick overview of the whole business here. So, this is essentially what my factory looks like at this point. It's almost able to be fit all on one screen, but not quite. Right now, see, I'm at about 41,000 platform units and over a million units, and it's chugging pretty bad. All right, the frame counter up here is not accurate because I just changed some display settings, but it's only at about 12, and that's with a 5900X 12 core and a 7900 XT 20 gigabyte video card, 32 gigs of RAM. It's just heavily CPU bound right now. Ran a FPS monitor a little bit ago, and it's just got one core bouncing off 100%. And yeah, so they got some optimizations to do, but it still works just fine, and it hasn't crashed to its credit. All the milestones have been kind of worked over, except for milestone 5. It's still pretty. I was still kind of learning when I put that one together. The other ones have been reasonably well um, upgraded as time went by. I've got two random operator Make Anything machine versions going right now. That's Op 0. I've got four of them. Op 0, I have to look around. A, B, C, and D. And then I've got three random operator 1 Make Anything machines going. Op 1A, Op 1B is around here. There it is. And then Op 1C. So um, I think the Make Anything machines are probably the more interesting. I've made some optimizations since the last video I posted and trimmed things down, worked a little bit more on integration, and left some of the I don't know, modularity behind where I was using a lot of space belts and space pipes. So we'll zoom in on Op 1 Charlie here. It's a pretty good representative, and I sure wish they had zoom to mouse. Hopefully they'll come out with that pretty soon, because it would make zoom in a lot easier. You have to zoom, move it a little bit, zoom, move it a little bit. It's really annoying. Anyhow, back to the business here. So actually I'll zoom back out just a bit, and um, with the third version of this, I've come to the conclusion that I need to have all my shapes on the right hand side or the east, and my colors tend to be on the western side, so my trains work out pretty well. One thing I wish they would do is make these shape and fluid loaders and unloaders, and basically the train tracks themselves, able to be easily switched, because I'd like to have my trains running the other way. Sometimes you have to redo all of the loaders and unloaders to fix that. So I wind up with these train paths sometimes that look like they make um, loops and things that they don't really have to. But I like to be able to cut and copy and paste as much as possible. So sometimes I'll sacrifice a little efficiency in the rail lines for the ability to keep things uniform and oriented north, south, east, and west, because it just makes it easier for me. So I've got this stuff crammed kind of together, but essentially this is the shape feeding pipeline here. With I take a look and see which shapes are required. I usually like to have two full belts. That's 3 layers thick, two full belts of each shape, and then I strip them down to the individual quadrants to use. And that's pretty standard. So I took some time and made this breakout box, I guess you could call it, or multiplex, or whatever you want to call it. There's a couple different ways. I don't know, manifold, something like that. At any rate, it takes full belts, 3 layers thick, and splits it out into 4 single layer belts, which are easier for processing through the Make Anything machine. So I've got 2 of those running at the same time. So I try to transport full belts whenever possible. It just seems to make most sense that way. And so I've standardized on this orientation. You can kind of see it's a circle, square, and I don't know what you guys call this thing, but I just call it like a concave, or the symbol is W, but I have no idea what that stands for. I suppose I could look it up. And I call these little guys sharps. I don't know. It doesn't matter. So I got circles, squares, concaves, and sharps. And so that's what I work with. And I go over here. Those all get fed via individual colored trains to these assemblers. And so the assemblers essentially take in individual quads, and then it's at this point, and I got to zoom back out again just so you get the idea of the full procedure here. These two little fields right here in the middle, kind of easy to find, are where all the signals from the operator channels get propagated. And I'm using two completely separate algorithms right on for op0 and op1, just to see kind of pros and cons of both. So since we're actually looking at op1, let me move over here. Since we're looking at op1, this is the way I've got it. There's some limitations on how you can examine the different tools that you have for logic gates and simulated buildings. The simulated building, this guy here, it outputs the shape, type, and color of the northeast first layer quarter, and there's no change in that. And then you've got a shape destacker that simulate separating the top layer of a shape. So it's between those two. One is you're looking at the bottom right, top right corner, and the other one you're looking at the top layer. And so between those, you have to do some weird logic in order to get the layers separated into channels that you can output to the Make Anything machine. So this right here would be bringing in the shape that we're looking for, which is the random operator shape number 1. And then each one of these logic trees that branch off from the same thing splits it and then outputs the individual layers. And you can take a look at those individual circuits and pause it if you want to. And this doggone autosave, it's always when I'm in the middle of doing something. I'm sure it'll go off at least one more time while we're talking. So you wind up with the base with the 4 layers represented here. All right, so base layer 1, base layer 2, and 3 and 4, and that's the top for what I'm playing on as a normal level. So that's where all the signals go. The colors of these little outputters give you a clue as to what's going on. So base layer 1 is going to be magenta, 2 is yellow, and then 3 is going to be white, and then the last one is the uncolored. It's nice. I wish I had about 20 more channels. It would really open up some possibilities to do things. But with the 8 channels right now, I'm using 4 for operator channel 0 and 4 of them for operator 1. So those are where the actual signals are coming from to tell the Make Anything machines what to actually make and process. So as we come down here, we've already taken the individual shapes, broke them out, put them on trains, and delivered them to the first stage of the assemblers here. And so the first stage of the assembler essentially just takes the individual raw shapes, and this is not by any means smart, okay? This is just works, but it's the only way that I could think to come up with it in a reasonably efficient manner. So essentially these are the same receivers on all 4 of these platforms, and they just look to see if this shape belongs in any of the lanes. All right, and I've just standardized on the order of lanes as northeast, southeast, southwest, and north from left to right. And so are there any circles in this actual layer? If we zoom in and look at what the layer looks like, there is a crystal that's circular, but that doesn't count. But yes, it looks like the southeast corner of this layer is a circle, and so you see essentially it's going to let only that southeast corner through. And now they all come in northeast, but they get spun around before they're allowed to progress essentially. So, well, if they are allowed to progress, then they actually get spun around. Now I know the rest of them kind of get left behind. There's a potential there to funnel them all back in if it was needed to, and I can make that optimization later. But for right now, it's only going to be outputting 1 lane regardless. So essentially, each one of the different shapes is going to run that evaluation and let through those places where the shape makes sense. And so once that happens, then this is just basically a multiplexer that puts them in their normal respective order. So these are the four quadrants of that layer right there: northeast, southeast, southwest, and northwest. And right here is where they're going to get combined. I'm sorry, now before they get combined into an individual layer, they're going to get painted. And because a layer can have multiple different colors on each of the quadrants. And so again, we're going to take a look at what the layer looks like by examining that channel. Got a little example there, so I don't want to keep zooming in because it's so cumbersome. But essentially, it's going to look at that layer and decide whether or not. And again, this is kind of a brute force way of doing this, but I'm not sure that I know a more elegant way. So essentially, the logic over here is just taking a look at each quadrant and seeing what color it is. And if it's a color that we have represented here, and we've represented all the colors, I'll show you the color supply chain here in a second. It's going to just basically, each one of these lanes has every color in it. So RGB CMYK essentially is the color that we have. We fit it all on a triple platform. And so yeah, that was a nightmare trying to get all those pipes where they needed to go, plus all the circuits where they needed to go. So yeah, I was going blind after that one, but it got made. And so essentially these will bypass all of the painters if they're not needed to be painted. For this particular layer, it looks to me like the two sharps in the southwest and northwest corner need to be painted cyan. All right, and so it looks to me like the let's see, which ones are those? Those are the two on the right, I guess. And so yeah, they're going to get painted. And there they are. I'll just zoom in a little bit more, and they are in action right there. And it just looks so cool. I love this game. The colors and the detail looks great. I wish the frame rate was a little bit better. They've definitely got some optimizations to do. I'm pretty proud of these little painter modules. I've got 4 painters crammed into the smallest possible spot that I could get them into. You may be able to do better, I don't know. At any rate, we got a bunch of them all on this same platform, and they're getting their paint from, this is a second, third version of this this kind of manifold here. So this is already with the paint mix, and so it's fairly straightforward. God, it's so laggy, especially when I'm taking video like this, even though it shouldn't. At any rate, the colors are delivered in these different train sections here. I'll zoom out and show you how those colors got here in a minute. But they come into this manifold here. This is a recent creation, just to make it a little bit more compact. The last one was a 3x3. I've gotten it down now into 2 north-south layers instead of 3. And also reposition some of this. Anyway, cut out a lot of the junk. So once the colors arrive and they get processed all through here, then it's at that point where the layers actually put together. All right, and yeah, super lag. Not much I can do about that, guys. Sorry. And so once they get painted, now we've got all of the different colors coming into this station, and that's where they get assembled. And so this logic over here just makes sure that none of the stackers stall out, because the stackers, if they stall, it stops the whole pipeline. And so things need to be able to bypass the stackers. And so you have a logic circuit for each branch and bypass of the 3 stackers there. So this is northeast and southeast getting put together, the southwest, northwest getting put together, and then of course the final things there. And so this is basically the controller circuitry that's telling the gates when to open and close. And it also has to be tolerant of nulls and crystals. So nulls and crystals will stall these because they're not blank. Well, they are. It's hard to explain. I'm not even going to go into that right now. It'll get really deep really fast, and it's not entirely I think maybe final product they might make some changes to the way the logic gates work. Before I go any farther, I'll zoom back out for a second just to show you how the colors actually get here. You can see that my standardization RGB CMYK comes in on a train there, gets dropped off, and that one train is servicing, well, in this particular case, it's about, I think, let's say 1, 2, 3, 4, 5, 8. And it seems like that's not much paint to service these, but in reality, not very many colors are used simultaneously. Just random chance dictates that you're not going to have 7 different colors on every shape. It just doesn't seem to work out that way. So I haven't had a problem with the bottleneck on the colors. You can see that they're all filled up, so that they're definitely not holding up the chain. Those come from out here a little bit, and so when I set up a new Make Anything machine, I try to find 3 color islands that are somewhat located where they'll be complementary, because I've got to have all 3 of those in order to create the different colors that the game allows. And so in order to get all those, and this was kind of either a masterpiece or a nightmare depending on how you want to put it. It took me a long time to make this thing. But essentially it takes 3 in of all the primary colors, and then it outputs 3 7 series of the subsidiary colors and the primary colors. So RGB, CMYK, those are all the different colors that can be used. You just don't know what you're going to need. So the idea is that I've got 3 of each. All right, and that's enough to satisfy that Make Anything machine with the 7. Well, 8, I guess, different stations. So 3 stations here constantly being fed, because we've got 3 colors in. So anyway, it seems to work out pretty well. It hasn't proved to be a bottleneck, and so that's providing the colors. And since I'm using trains back and forth between this station and this station, the number of stops that the trains make here is arbitrary, and it doesn't have to be a multiple or the same as the number of stops the train makes up here, as long as the order of the loaders and unloaders is consistent among the stops. And so I've made sure to do that. That's just something you got to do for every one that you make. So at any rate, after it leaves the assembler, then the last step here is to decide whether it needs to be crystallized or not. And in this case, that first layer did have a the southeast quadrant needs to be crystallized. And so again, now this works very much the same as the painter, except in reverse. And what I mean by that is that crystallizers require 2 inputs per saturated belt per unit rather than just 1. And so if I was to do it the way I did the regular painter, there would need to be 2 leads to every single one of those paint stations. And so it made it easier to write one big mixer here and then just control the valves to the individual colors. And so the logic is a little bit more cumbersome. I joked about it being like Apollo era, and that's kind of just because of the limitations on what they allow you to do here. And so you've got these case statements essentially. So each one of these 4, I guess we'll call them rows here, represents 1 quadrant of the shape. And so basically you're checking each quadrant to see if the color matches this particular lane's color, and there's 7 colors there, so I've got to have 7 columns essentially. So these are the 7 colors, these are the 4 rows or 4 quadrants. And so if any of them determine that there's a quadrant with a crystal in it and it matches a particular color, and you can see that this data line here is the only one that's active right now, and it goes down to, sure would be nice to have that zoom to mouse, if you it'll open these valves. And so when it does, it makes this entire thing white, but it doesn't matter, it doesn't backfeed or anything like that. So when it selects a different color, and never will there be more than 1 color at the same time activated, it just saturates the line into the mixer with that particular color, and it's essentially instantaneous. It works very well, and that way we get the color where we need it. Now this game is just so beautiful. I mean, I just love how these manifolds look once they're all put together. I mean, that just looks so freaking cool right there. I mean, am I just nerding out on that or what? Um, Without OBS copying, it's a little bit smoother than this. But if this was buttery smooth at 120 frames per second, I just don't think I'd even get up to eat. And so essentially, this is the same process that we're going to use to process the different layers of each one of the random shapes. And so as we get zoomed back out here laboriously, we can roll through here. Now with each layer, there is some specific logic that goes along with making sure that we're not going to that we're going to handle exceptions. So as we get deeper in, especially with the last layer, I'll just skip to the end here. With the last layer, weird things can happen. Number one, if there's a crystal taking up the entire top layer, that means that you'd have to have pins up there. And if you've got pins up there, because you can't just crystallize a layer without anything. It's weird. It's the way the crystallization process works. A little bit of trial and error. Essentially, you have to create a dummy layer, bounce it off the top, and leave the pins behind, and then the crystallizer will crystallize around where those pins were. And so, with each of my Make Anything machines that supports crystals, and pins too. I have to just import some random shapes from the nearest supply. They're not coming through the normal shape supply line because it's irrelevant what shape they actually are. What's important is that I can create some dummy layers that will either make pins that protrude based on the shape, or that will create a structure for the crystallization process to activate on. So essentially, this is not optimized, by the way. This was a proof of concept that works, and so I left it alone. It takes some shapes in here, make sure that they're all in a predictable spot. I don't know why I selected northwest in this particular instance, and the green makes no difference because this is essentially a sacrificial layer. So this guy here is going to be monitoring the top layer, and just to make sure that if any of the positions on the top layer are exposed pins, then once again it's going to look at each different quadrant of the shape to see where any pins reside. And even though these are all the same, what I'm doing is rotating the the output of this particular thing either 90, 270, or 180 in order to examine it against, because you can only, well, anyways, it doesn't really matter. You can only look at the northeast corner at a time. So if you want to look at a different corner, you have to rotate the object 2 or 3 times before you inspect it in order for it. Anyways, it doesn't matter. I suppose I could have 4 different samples here, but it wouldn't matter because you still have to no, never mind, I don't want to go down that route. Anyways, just limitations on the logic circuits there, or my brain, one of the two. So what it does is it creates a dummy layer, and if the conditions are right, then it will allow that number. And yeah, you're gonna kind of laugh at this, but essentially I just hijacked this lane, brought it out to this platform because I knew I wasn't going to have room for the logic on the platform itself, because I was still doping it out, and the stackers, by the way. So essentially it's just going to create a false layer, and when it creates that false layer, if the conditions are right, it'll try to stack it on top of this shape that's already been in the pipeline, this layer cake. And since that will usually put it over the maximum layer for the shapes, it'll leave the pins behind. And so if it leaves the pins behind, I guess the smart part about this is that if there's exposed pins on the top, you have to match those. And so this logic is essentially making sure that my created on the fly shape actually has the pins in the right spot once it's stacked on top of something else. If it's just getting crystallized, it doesn't matter where the pins are. As long as there's one pin, the whole layer will get crystallized. So when I first was putting this together, I just had this thing that just plopped any old piece on top. But if you've got exposed pins in particular spots, which now I do on after level 100, it started throwing pins on the top. It was the very first time I had. Anyway, I had to make sure that this was working. So that's the handles the exposed pins and crystallization on the top layer. And then this is also the final assembly, as it puts this with the layer that was below. Um, if it's crystal or empty, then it just bypasses. And then it's a special case. If it's all crystal, then it's going to add a dummy layer. And so this is distinct from the pins. And this existed first. That's why it's not integrated with the other one. In fact, all three of these could probably be integrated together. I just haven't got around to doing that yet. Anyway, it looks like I just got another operator level. That one was Milestone 1. I'll claim that while I'm here. Pretty respectable on most of these. I had a couple that were stalled out for a while, but all of these levels for Operator 0, 106 and 103 were done with the Make Anything machine. So no hand doing this. If I encountered a problem, I'd fix the machine and make it handle an exception. And I had to do that a few times when this one first started and a few times when this first started. But since then, they've been handling pretty good. It's just that the total number required keeps going up. And honestly, the frame rate is so bad right now that even though I could add an arbitrary number of operator Make Anything machines for both of these, and really all the milestones, it's just going to make the game so unresponsive as to not be playable. So instead, I've just been trying to go around to all my existing machines and start cutting down on the platform count and the unit count if possible. But it seems to me like they kind of go at cross purposes. The more integration you have, the more it seems like your unit count goes up, and the more belts and space pipes that you have, the more your platform count goes up. And I'm not sure which is worse for performance, but I'm dealing with at least 1 million units right now. And like I said, I think over where was it? Hell, I had it a second ago there. Yeah, it was like 41.5 out of 119. There's no way if I had 119,000 platform units out there that this game would run at all right now. So I mean, it might, but it would be at a crawl. So once the save game comes out, I just wanted to briefly go over that was it essentially. Once it passes those last few final checks, it's going to go through the last crystallizer, which will if necessary crystallize that top layer. And if that's the case, then we got the little truth check at the end, which for the Make Anything machines, I like to make sure that I do this for each one because I want to actually see that it's making the right thing. And it's very satisfying when those first ones starts jumping out and it doesn't keep chunking them into the trash, because it does take about anywhere from about 6 to 10 minutes to flush the system when you start over with a new requested item. And when that request comes through, it's got to clear out the pipeline of all the old junk. And so, 5 to 6 minutes. It was about 10 minutes, but by getting rid of a lot of the spaces in between the individual assembler units, that really helped out a lot. So lots of stuff going on here. I really enjoy this game a lot. I love the challenge of putting together the machines. The spatial relationships of those machines continues to challenge me. I like it's just a puzzle, and putting together the logic to operate the gates to the different machines, and making sure that the Make Anything machines handle all the different exception cases. While we're here, just really quick, the Operator 0 one, so the Op 1A should be able to handle just about anything the game will chuck on normal difficulty. And Op 0 has not encountered any crystals yet, so it's quite a bit more compact. So it has basically the same 4 assembler units as the Op 1 does, but it lacks the crystallizer. And so because of that, the whole thing is a little bit more compact. And if they haven't introduced crystals by now on Op 0 on normal level, they probably won't. Nothing tells you whether or not they're going to chuck you a particular thing. So I really worried at the beginning whether I was going to encounter things that would break the model like right away. And so they kind of baby stepped it into both of these. Best I can tell, there's no There's no crystals on this one, and there weren't any exposed pins on this one until level like 102. So this one's focused mostly on crystals. This one's focused mostly on just putting together layers, kind of traditional stuff without crystals, but it does have pins, and so you got to be able to handle that. The the milestones are just the milestones, and they're fun to build. Those are the last kind of parting things that I'll say. I'll just put the other thing back up there because it's more fun to look at this while I'm talking, and most of the time I don't talk, so I'm going to go ahead and just finish out most of my thoughts here. Is that when you're doing the milestones, I kind of liken those to ASICs. They're application specific. You can really custom tailor the individual platforms and supply lines to get the most out of what you're trying to make, and you can usually have a much more efficient per platform, per unit output compared to using the make anything machines, because each one of those make anything machines basically just puts out one individual lane, not one belt but one lane, and so that's only like 1/12 of what a fully saturated belt would be. And so even with only 3 or 4 of them, that the total output of my make anything machines is pretty low. But when it comes to the milestones, you can be a little bit more brute force with it. Let's see, which is a good example. I recently went back and did milestone 6. I just re-upped this one, and I got it a little bit more efficient now. And see, from the shape supply, you can see that you can really go to town putting together a lot of shapes for the trains, and because you know what you need, and you can just make sure that you're lossless as much as possible through the selective choice of the mining stations that you're using. And then the crystallizers are still not that efficient, so I've got some work to do on those still. There's probably more integration capable with those, but the painting has gotten better. See, this one's dedicated to a single color, and so I optimized this a couple of days ago. Actually, I could probably shrink this even one more time, but compared to what it used to look like, you're taking all 3 colors in here and outputting all white, and white is a double mixed color, and so it's the most pain in the butt to actually make. But I went and redid the painting stations. I said I was going to finish out talking about this, and here I am rambling still. I'll go ahead and cover it. What I went to now is a more of a 3 parallel line process. In other words, a supply will come in from the north, a supply will come in from the south, and then the output will usually dodge and be parallel in the output as well. Now these could be either direction. It could come from right to left and left to right. You just have to tailor the loaders and unloaders to be in the proper orientation. But the heavy lifting is done pretty much with the mixers here. I've tried to eliminate as much of the fluid pipes as possible, and the space pipes as well, or the space belts as well, just to try to clean things up and save on platform count. Not entirely successful all the time. At any rate, we can get some pretty good output from, like, here's a shape combiner. This is my most recent shape combiner, and stackers are just not all that easy to make, really. This might look really cumbersome and crude, but I challenge you to make a better one. If you do, more power to you, but your head will hurt trying to put these things together in any way that makes sense. So it's taking an input on left and right and then outputting it to the side to get it out, and that way we can kind of continue to stack these one right against each other. If you output linearly, then you're going to have to get them around the things that are in front. So seems like a pretty efficient way to do it. I tried other ways first where the supplies are to the left or the bottom and 90 degrees to one another, and then ejecting out the third direction. And there's limitations there. In fact, the make anything machines kind of follow that process, and it's okay. Um, but I'm leaning towards this style of integration as time goes by, because it just seems a lot more compact and easier to get the trains in and out. So having said that, you can see there's different iterations that I went through. Like, this is kind of when I was doing a lot of the research. Modularity is king, and being able to quickly construct new pipelines to make a particular shape that's requested is paramount. And so having a library of modules where you can just connect them like Legos is really a bonus. And so that's kind of an example. This is Milestone 1 Alpha. There's a couple other Milestone ones, but it's pumping out pretty good. This one's got some good output. This is a fully saturated, I think I got 6 fully saturated belts outputting Milestone 1. So 1, 2, 3, 4, 5, yeah, 6 fully saturated. So that's 3 layers all getting in there. So this one's pretty good. If you had all 6 of those, it would be 18,000 units. So that's pretty good. And I'd like to get all the milestones up to that, but realistically, the milestones require so many units in order to advance that, I mean, you know, at some point it just becomes ridiculous. So Milestone 1, for example, that needs almost 19 million to get to the next level. And the other ones are, this one is sorely lacking. It's about to pop again, but we can still do some work on Milestone 3. But the rest of them are up there pretty good. And then, of course, I'm making most of my operator levels now on the Op 0 and Op 1. And I'll probably need to get another couple instances of each one of these going. Ideally, I'd abandon this one and just basically make all of one and make sure that it can do both. And I think now that this one can do pins, it'll pretty much do everything this one will do, but at a higher unit budget. So as long as this one keeps working, I'll leave those in play. But eventually I'd like to just make one that will do everything, and then just make massive instances of it. So anyway, that's a long, involved update, but pretty much shows the state of my game right now. I appreciate you guys watching. Listen, I'm not an expert on factory games. I picked this one up. My son actually forwarded it to me, and it's awesome, and I appreciate that. But I'm not a long-time factory game player. As you know, some of my methods might seem completely ass backwards, and that's fine. It seems to be working okay right now, but I really do enjoy figuring out this stuff on my own. So I kind of work in a vacuum all the time. I don't look at other people's work. I don't want to be shown how to do things, because that's the whole point of playing games, is to kind of discover it on your own. At least that's the way I feel. So this is all my work. If you appreciate it, throw me a like or a comment down there. Tell me how you did it instead. I'm really kind of curious. Now that I've got things working, I've pretty well maxed out this release candidate. This is just release candidate 008. Can't wait to see the full game. Hopefully there's some more optimizations. At this point, I'm just babbling a little bit, but again, thanks for tuning in. Like, subscribe, give me a comment, and I'll catch you guys later. Thanks.